So in this worksheet, we're going to be talking about different ways to have sampling bias. And that means that your method of sampling, or the people you talk to, or the data you're gathering is not representative of the population as a whole. Ideally, the people in your sample look like a subset made up similarly to how the population is made up of. So if the population is skewed right, your sample should be skewed right. If your population is normal, your sample should be normal. Okay? So, the survey is said to contain bias. Bias may be introduced by selecting a sample that is not representative of the population, by the wording of the survey question, by the presentation of the survey, of the results of the survey. So, you could even collect good data and look at it from a specific angle that misrepresents the sample, and that would be bias. It's over here somewhere. What is it? Is that 3.1?
Yeah.
They're on the Chromebooks.
Oh, they're still on the Chromebook card. No. I'll get you one in a second. All right, so here are some common biases. Response bias. Response bias happens when the person responding does not have complete freedom over their answers. The most common would be when the interviewer is influencing what the respondent says, right? When you tell a story to your friends and you tell the same story to your parents, it's not always exactly the same story, right? That would be response bias. The presence of the interviewer influences the response. So this says the type of bias which can affect the results of a statistical survey if respondents answer questions in the way they think the questionnaire wants them to answer rather than according to their true beliefs. Or any other way that the response is affected by the person asking the questions. Okay, measurement bias. So measurement bias would be if you had a tape measure that was missing the first inch, and you use that tape measure, every measurement's going to be off. Okay? If you had a scale, remember the old scales you stand on and then the arm swung? If the arm swings to 5 pounds and doesn't zero out, then every measurement's going to be off by 5 pounds. So if your measuring device is not accurate, then that would be measurement bias. It could also be, if you don't know how to read a tape measure, right, then you could have measurement bias in that way. Non-response bias. So a lot of times the option to be part of the sample is decided upon by the respondents. So you have to ask, are the people who responded categorically different from the people who don't respond? And you get that a lot in like Amazon reviews. People give Amazon reviews if they're really happy, or they're really mad, or they're just one of those people who thinks that their life revolves around reviews. If you're like, the product was all right, you're probably not going to spend the time responding.
What if they were paid to review?
Oh, so is it okay to pay people? And the statistics community says yes, that's okay. Now, could that be a non-response bias? Like, if you answer this survey, it'll take you 20 minutes, I'll give you $20, right? If $20 means a lot to you, you might say yeah. If $20 is not worth 20 minutes, then you're gonna say yes, and you would have some non-response bias in that case. But it still is a really common way to gather information, is to pay people. And statisticians, good statisticians, find ways to sort of weed out the bias. So, have you guys ever done a Sharp survey? Anyway, not every year. I think they do it every 2 years. But when there is a presidential election, or any election really, people run around and talk to the community and say, who are you gonna vote for, who are you gonna vote for, who are you gonna vote for? And they use those numbers to predict who's gonna win, right? But some of those people have never voted in their life. So the questionnaires are written very specifically to help researchers weed out the people who they shouldn't count. So one of the questions will be, are you registered to vote? If the answer is no, your survey gets thrown away. It's not included. Another question they like to ask is, how likely do you think you are to vote? Did you vote last time? Did you vote in the last election? If you say yes, then they're gonna keep your survey. If you say no, they're probably gonna throw it away. And they've developed a lot of tools to weed out these biases by asking really specific questions. Okay, selection bias. So is your selection bias leaning in one direction or the other? So if we were trying to figure out the average wage of kids at every high school, I don't want to just go talk to the football team, right? My selection is biased in that the football team does not represent the school as a whole. Now, you don't need your sample to be similar, like homogeneous. You want your people in the sample to differ just as much as the people of the population differ. So your sample needs to look like a smaller version of the population as a whole. If it doesn't, then there's probably some sort of bias in there. And then recall bias. Recall bias is when you ask questions to people about events that have happened in the past. And we are terrible at remembering things. And especially if you go back a year or 2 years or 5 years or 10 years, you can't really trust that information. If people are remembering a bad event, they're probably going to make it worse. If they're remembering a good event, they're probably going to make that event, they're going to bias that event to the good side. So, you have a whole bunch of questions or scenarios. In each scenario, you're going to determine what type of bias is it. And it might actually have two different options. Okay. And that will get you to number 13. All right, so simple random sample. In order for something to be a simple random sample, two things must be true. First, each member of the population is equally likely to be chosen, and the members of the samples are chosen independently of one another. Now, simple random samples are king. That is what we strive for in statistics. It's not always possible, but doing a simple random sample is the best way to ensure that your sample looks like the population. Now, these rules are only maybe 75 years old. This branch of statistics is relatively new in the mathematics field. Most math things that you've learned are centuries or millennium old. But statistics is relatively new, and we have developed these new statistics theories mostly because we screwed it up in the past. So back in right in the Depression, 1930s, FDR was running against somebody who I forgot his name. And there was this this magazine that predicted that FDR was going to lose. It's not the Reader's Digest, it was some other digest. But they did a survey, get this, of 10 million people. They sent out a survey to 10 million people. Well, they sent out more than that, but they got 10 million responses. Was it a million? Whatever, it's a lot. I think, anyway. And they ended up saying FDR is going to lose by like 15 percentage points. And they were wrong. FDR won, and the magazine went out of business. They literally lost all their subscribers because of this claim, and they went bankrupt, and the magazine no longer applies. So here's where they messed up. They sent, they looked at like club lists, like country club lists or the Elks Club, and they used telephone books, and they mailed out millions of surveys to people on these lists. And then the people filled out the survey and sent it back in, and they tabulated millions of responses, and they ended up being wrong. Because are the people whose names appear in phone books in the 1930s or in these fancy membership club lists, are they categorically different from the population as a whole?
Yes.
Oh yeah, those are all wealthy people. So they sent the survey to wealthy people, got back, and they had 1 million or so responses. And the wealthy people voted one way, but the poor people in the Depression voted the other way, and FDR won by a landslide. And this magazine, their reputation was ruined, and shortly, like within a year, they went out of business. So that would be sampling bias. They were picking from a sample that did not represent the population. So in their method, was each member of the population equally likely to be chosen? No. If your address did not appear on any of these lists, what was your chance of being chosen? Zero. Okay? And once one person is picked, the next person picked cannot be influenced by the first person that was picked. Okay? And that one's a little less obvious why that's the case, but like picking picking Addie Johansson, like, oh, I know her, I know some other Johanssons, so I'm going to pick them too, right? That would not be a simple random sample. Okay. One way to do simple random samples, supposedly, was generating random numbers electronically is very, very difficult to do. So one way they used to do it is they took the first billion, well, probably million or so, digits of pi. And then they would ask the computer, randomly pick a 3-digit number in that reference of pi. So when you turn a computer on, it keeps track of how long the computer's been on. It's got a clock, right? And so if you say, pick a random number, the computer would look at the clock to basically see what time it was since the computer was turned on, and then it would use that to, right, it would read through the digits of pi until it reached that moment, and then it would pick that 3-digit number. Is that a simple random sample? Well, what if your 4-digit number was 1783? And that number does not appear anywhere in the first million digits of pi. What's your chance of being chosen? 0. So that was the best they could do to get a random number generator. And your calculators today, like if you have a graphing calculator, you can ask it to spit out a random number. And it's not truly random. It takes into account how long the calculator's been on, and the calculator probably has some kind of time and date system in there, and then it will take the last 5 entries that you have computed, and then some other data, and it will multiply them all together and come up with this big number, and then pick a certain number of digits inside that. It's not truly random. There are people who make a living generating random numbers. So there's a guy who built this giant apparatus, and there are like 100 jars, and in every jar is a 10-sided dice, and on the top of every jar is a camera. And so he can go over and shake this device, and 100 dice roll, and there are 100 cameras, and he's written a computer program that looks down and reads the number of the dice, and then inputs that into a spreadsheet, and people buy those lists of random numbers from him. And they say, hey, we need 1 million random numbers. And he spends the day, shake, record, and he generates these lists of random numbers, and then companies buy them because those are truly random. There are some things we can do on the atomic level something to do with the position of electrons that are random. I don't understand it, but generating random numbers electronically is very, very, very difficult. So, and if I asked you, pick a random number between 1 and 10. 6. Do you really think that was a random number? Well, she said 6, not 6.87273518721. Right? So she limited herself to a whole number, and if you were to do that over and over and over, we would be able to find a pattern in it. You probably aren't going to pick 1 and 10 very often. But they should appear equally often. So as people, we're terrible at generating random numbers. Okay, so that is a simple random sample. So on this second page, you're going to go through and try to figure out, does that description represent a simple random sample? And you're going to test it against these two stipulations. Does every person in the population have an equal chance of being chosen? And does the choice of one person affect the choice of any other person? Okay? Is that going to take us to the end? Yes. All right. Here are the answers.